Alright, so here's my video for direct variation. What I'm going to do here is I'm going to go over just the assignment that I gave for direct variation. Again, I only asked you guys to work the front here. I feel like that was enough. A couple of things about direct variation, just real quick, and this is some of the things we covered in class. With direct variation, all we're really dealing with is the slope of an equation. Direct variation is usually written with a k for a constant of variation. That's one of our key terms. You can also think of it as just with slope. One of the important key things here is that the intercept, the y-intercept, is going to be 0, 0, which means our equations are not going to have a number added on to the end. Okay, and whenever we're graphing, our graphs are always going to have 0, 0 as a point. So for example, and what I'm going to do here is go down and do one problem out of each of these sets. So for this first one, tell whether the equation represents direct variation. A direct variation should only have slope written in it, and it should look like this. And here we go. Y equals 8x. Okay, that matches. There's no number added or subtracted here at the end. Yes, that is direct variation. With these others, for instance, like number 3, first you'd have to go through and solve out for y equals, or like in class, you can use 0, 0 to check if the y-intercept works. For direct variation, for graphing, again, all that we're dealing with is the slope. And the y-intercept is 0, 0, I've already plotted that point. So now, with 1 being my rise and 2 being my run, I can then plot and move, get my next point, draw my line, and that would be done accurately or correctly. For instance, for number 5, first you'd have to solve for y, and once you have y equals whatever your k value is, whatever your slope is here, x, then you'd be able to take that 0, 0 and plot your graph after that. Okay, next set. So for number 7 here, the graph of a direct variation equation is shown. Okay, direct variation, y-intercept is 0, 0. Write the direct variation equation. Okay, so very simply you're being asked to come up with what is the constant of variation, or what is the slope going to be here. Okay, well, knowing that I have 0, 0 as a point, I can just measure over to this point here that they've given. So that's just recording the movement. 1, 2, 3. That's a rise of 3. And 1, 2. That's a run of 2. Okay, so if we're looking at this as slope, rise over run, then what we've got is a rise of 3 and a run of 2. So there's my slope, which means that my direct variation is going to be 3 over 2x. Now, a lot of people had questions about this second part here, and what this is simply saying is that if x is 10, so if I put in a 10 here instead of an x, then what's that y value going to be? So whatever 3 over 2 times 10 is, that's the number that you would use, and that's going to be the answer for the second blank here. So again, for the second blank, it's if x is 10, then y equals what? Okay. Now, for 10, 11, and 12, this I probably got the most kickback on. What's going on here is this is very similar to what we did in class whenever we're dealing with x and y values. So what you're being asked here is tell whether the table represents direct variation. So again, what you're being asked is just yes or no, is it direct variation, like 1, 2, and 3. So then here, for example, for number 10, okay, if x is 0.5 and y is 9, then if this is a direct variation, then I should be able to write out the equation like that. Now, one of the things about this is that I'm going to be able to figure out what the slope is. And whenever I do that, I come up with the slope being, if you divide those, that's a 0.5. If you divide those, you get 18. Okay, so if I use that 18 and test these other numbers, I should be able to come up with the same slope. So there's my y value, there's my x value. All right. And what do you know? The slope equals 18. There we go. All right, so that would prove that this is a direct variation. And once you have the slope, you can write out the equation without much trouble. So there's your direct variation video. This assignment is due tomorrow, so please have it done and ready to turn in.